Okay, hello everybody. So today we're going to continue our discussion on Chapter 3, Section 4. And as I had mentioned in a previous video, that there are ways to be able to cut down on the amount of numbers that you get whenever you do the rational root theorem and come up with a bunch of possible zeros. Now, I have mentioned in prior sessions that I don't mind if you use your graphing calculator to help you cut down on those number of zeros, but you're not always going to have the opportunity to use your graphing calculator. So therefore, we need a way to be able to cut back on some of those numbers. So when you get a list of 12 or 15 or 18, or wouldn't be 50 to be even number, if you get a ton of those P over Q numbers, we have a way to cut them down so you don't have to try all of them. And so there's a couple ways to do that. The first way we're going to talk about is what is called Descartes' rule of signs. And what Descartes' rule of sign allows us to do is to figure out the possible number of positive numbers that could work and the possible number of negative numbers that can work. And it's kind of two different tests in one. You can read this. It's probably just easier for me to show you how the actual test works. But what it looks for is a variation in sign between each of the terms in the polynomial. So as an example, if you look at this function f of x equals 3x cubed minus 5x squared plus 6x minus 4, you can see that the first term is positive and then the second term is negative. So because we have two terms side by side and it goes from a positive to a negative, that is a variation in sign. Now, looking at the next two terms, you can see this one is negative, and then it goes back to a positive. So there is another variation in sign. It goes from negative to positive. And now looking at the last two terms, you can see it's a positive 6x and then a negative 4. And there again, we have a variation of sign because it goes from positive to negative. So it goes from positive to negative, and then negative to positive, and then positive to negative again. And so what you see is there are three variations in sign. And what that tells us then is that three of the possible positive numbers from P over Q could work. So let's actually do the P over Q for a second. So here's P, there's Q. So P is going to be plus or minus 1, 2, and 4. Q is going to be plus or minus 1 or 3. So listing all of these numbers out, we would have plus or minus 1, 2, 4, 1/3, 2/3, and 4/3. Now, there are 6 numbers listed there, but when you actually write them out with their positives and negatives, there would be 12. And the amount of numbers would be 1, 2, 4, 1/3, 2/3, 4/3, or -1, -2, -4, -1/3, -2/3, and -4/3. So if we list them out without just writing the plus or minus, but listing them, you can see there's 12 numbers. That's a lot of numbers. There's a lot of fractions in there. To sit down and try to do synthetic division to just find one that works would be a lot of work. And so we need a way to be able to cut back on how many numbers that we're going to try. And so the Descartes rule of signs is what allows us to do that. So looking at the first part of Descartes' rule of signs, there are 3 sign variations, which means out of these 6 numbers, we could possibly have 3 of them work. Now, that doesn't mean 3 of them will work, and it's always reduced by 2. So we could either have 3 work or we could have 1 work. Now, to look at the negatives and to determine how many of the negatives might work, there's the second part of Descartes' rule of signs. And what that tells us is that we take our original function. Remember, our original function was simply f of x equals 3x cubed minus 5x squared plus 6x minus 4. But everywhere where there was an x, I now substituted in negative x. Now, what I have to do from there is to simplify this. So I need to cube the negative x. When I cube a negative, it's going to put the negative out in front of the 3 because a negative times a negative times a negative is still negative. So you can see 3 parentheses negative x to the third becomes negative 3x to the third. But looking ahead to the next term, when I substitute this negative x in, once I square it, that thing just turns into a regular x. It goes away because when you square a negative, it becomes positive. So this term stays minus 5x squared. Now looking ahead to the next term, you can see I substituted negative x in right there. When I multiply 6 times negative x, I get negative 6x. And lastly, the negative 4 just comes down. And so what you see now is we have a new polynomial. This new polynomial has 0 sign changes. And we can see that because this is negative, 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 negative. Every term is negative. There are 0 sign changes. Okay, now why does that matter? Well, what that tells us, because there were no sign changes after we substituted negative x in, none of these negative numbers up here, none of these will work. None of them, because there are no sign changes when we tried the Descartes rule of signs. So as you can see, this is a pretty valuable tool to be able to cut down on the amount of numbers that you might need to try when you're using synthetic division, especially when you don't have a graphing calculator. So we know now that 3 or 1 of these could work, which doesn't really help us cut down that list too much, but we also know that none of the negatives will work. So that completely eliminated those, cutting our list of numbers in half. Now, there is a second part to this where we can set an upper bound and a lower bound to the number of numbers that we have. And it has to do with whenever we do synthetic division and interpreting the answer that we get. And so it says another test for zeros of a polynomial function is related to the sign pattern in the last row of the synthetic division array. So what we want to do is when you actually try a number and you do synthetic division, the last row of numbers that you get down at the bottom, depending on the pattern of the signs there, that can tell you whether that number is the maximum number or the minimum number that could work. And so here's what it says. It says if f of x is a polynomial with real coefficients and a positive leading coefficient, suppose f of x is divided by x minus c using synthetic division. If c is greater than 0, so the number that you're dividing by is greater than 0, and each number in the last row is either positive or 0, then c is an upper bound. And it says c, so again, the number that you're dividing by, if it's less than 0, and the numbers in the last row are alternatively positive and negative, then that number is a lower bound. And I'm going to show you how that works here in just a second. So this says find all real zeros of 6x cubed minus 4x squared plus 3x minus 2. First thing we're going to do is we're going to do the p over q. So p is plus or minus 1 and 2. Q is plus or minus 1, 2, 3, and 6. All right. So we have a bunch of numbers here. The numbers are 1, 2, and then we have 1/2. 2/2 would be 1. We already have that listed. Then we have 1/3, and then we have 2/3, and then we have 1/6, and then we would have 2/6. 2/6 is 1/3. We already have that listed, so we don't need to list that again. So there are a bunch of numbers there. There are 6 times 2, because one could be positive, one could be negative. There's actually 12 different numbers. Now, what I'm going to do is I'm actually going to list these from least to greatest. And you'll see why I do this in a second. So we're going to start with -2. Then we would have -1. And then we would have, let's see here. I'm actually going to start with 1 and 2 would be the last one. We would have 1/6. Then we would have 1/3. We'd have 1/2, 2/3, 1, and then 2. So I got 1/2, 1/3, 1/6, 2/3, 1 and 2. Now working backwards from that, we would have negative 1/3, negative 1/2, negative 2/3, negative 1, and negative 2. So there are all 12 of those numbers listed from least to greatest. And I forgot 1/6, so I need to fix that. There should be a negative 1/6 right in there. So there should be a 1/6 and a negative 1/6. And then a negative 1/3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wanted to make sure I had all of them listed. Okay, so there are all the numbers listed as their positive and negative. So there's a lot of numbers, and there's a lot of fractions, not really fun to mess with. So we want to find all the zeros of this. Now remember, this is a cube, so if we can find one of the numbers that works, then we could just factor the rest of it. So the easiest number to start with would be, let's try 1. So I'm going to do synthetic division with 1. So I have a 6, a negative 4, a 3, and a negative 2. And I'm going to put a 1 right there. So 6 comes down, 6, 2, 2, 5, and then 5, and then I get 3. All right. So this is what this last little bit was talking about. I tried synthetic division with 1, and I ended up with all of these numbers. All of these numbers are positive, which tells me then that this 1 is an upper bound. This 1 is an upper bound. 1 did not work, but any numbers bigger than 1 will also not work. So I can eliminate 2 without even using it based on the answer that I got for 1. Now, don't forget about Descartes' rule of sign also. We should take a look at that. You can see I go from a positive to a negative. Then I go back to a positive. So there's a second sign change. Then I go to a negative. And there's another sign. There are 3 sign changes there, which means up to 3 of the positive numbers are going to work. Now, I just eliminated 2 of them. So here I could have either 3 or 1 of those still work. Now, I do want to plug in the negative x. So 6 negative x cubed minus 4 negative x squared plus 3 negative x minus 2. And so this becomes negative 6x cubed. This becomes minus 4x squared. This becomes minus 3x, and this becomes minus 2. So by substituting negative x in, you can see that my answer, my result, I ended up with all negative numbers. What that tells me is there are no sign changes. So the Descartes rule of sign, I can rule out every single negative number because there are no sign changes when I substitute it in negative x. So we're starting to cut this list down. We have 1/6, 1/3, 1/2, and 2/3. I would say out of all of those, 1/2 is probably going to be the easiest number to try next. So let's try it. We're going to do synthetic division again. 6, negative 4, 3, and negative 2. I'm going to try this with 1/2. Let's see if 1/2 will work. We drop the 6. 1/2 of 6 is 3. And so then negative 4 and 3 is negative 1. This gives me negative 1/2. And this gives me 2.5. And then half of 2.5 is 1.25. And we can clearly see this is not going to work. This would end up being negative 3/4 here. And so 1/2 didn't work. So we're going to eliminate 1/2. So we got to try it again. I'm going to try, why don't we try 1/6 this time and see if that works. I'm going to erase this just because I'm running out of room here. I actually don't want to try 1/6. And here, I'm going to try 2/3. Let's try 2/3. And so you can try, 6, negative 4, 3, and negative 2. Now, I actually should tell you why. Why am I going to try the number bigger? Well, here's the thing. I tried 1/2, and what I ended up with down here, I got an oscillating sign. I got a positive and I got a negative. Then I got a positive and I got a negative. When you try a positive number and you have all positives, that tells you it's an upper bound. We did not get that result. So that means that very possibly the number bigger than 1/2 could work, because 1/2 is not an upper bound. So I am going to try 2/3. So I'm going to erase this for a second. And I'm going to put in 2/3 right here. And I'm going to go back with my numbers: 6, -4, 3, and -2. Drop the 6. So 2/3 times 6. 6 divided by 3 is 2. 2 times 2 is 4. So that gives me 0, 0, 3. Now 2/3 times 3 is 2. And you can see I ended up getting 0 when I did synthetic division. So because this remainder is 0, that means x equals 2/3 is a number. Now what I'm left with is 6x squared plus 3. Now if I try to solve that, I end up getting a square root of -1/2. And so that's going to be an imaginary number. I'm not worried about you listing that imaginary number right now. So what we were able to determine, since 2/3 worked, x minus 2/3 is one of the factors. And then what we were left with was 6x squared plus 3. If you FOIL that back together, you would get the original polynomial. So what the directions said was find all real zeros of that polynomial. And the only real zero that we came up with, the other two were imaginary, was this x equals 2/3. So there you go, guys. That's how you use Descartes' rule of signs to eliminate some of your P over Q answers. But as I said in previous videos, I'm okay with you using your graphing calculator as well, which is a lot faster and easier than using this Descartes' rule of signs. But it's something that you still should be aware about. So have a good day. If you have any questions, feel free to email me.